The Cosmic Engineering Council adopted human standards because they simply work better. The alarm screamed through every corridor of station. Commander pressed his primary manipulator against the control panel, his three eyes scanning the readouts with growing horror. The massive station was tearing itself apart, and he had no idea why. Section 12 reports another pressure breach, his second officer announced. Her voice carried the trembling harmonics of fear. That's the fourth one this cycle. Had served the Cosmic Engineering Council for 30 years. He had built relay stations around dying stars and repaired quantum gates in the depths of dark matter clouds. He was a master of the precision standard, the measurement system that had guided galactic construction for 12,000 years. But right now, none of that mattered. Station was failing, and he couldn't stop it. The station connected 17 star systems. Millions of ships passed through it every day. If it exploded, the shockwave would collapse the entire relay network in this sector. Billions would be stranded. Thousands would die. Send the emergency codes again, ordered. Tell the council we need more engineers, better engineers, anyone who can help. The station shuddered. Metal groaned. Somewhere in the distance something exploded. 3 days earlier, the problems had seemed simple. A power coupling had failed in Section 9. Standard repair work. But once team opened the wall, they found a nightmare. The coupling was HAL manufacture, calibrated in gravitational flux units. It connected to a conduit measured in crystalline resonance frequencies. That conduit fed into a distribution node using quantum probability measurements. And all of it had been installed at different times by different species, who never talked to each other. The repair manual for the coupling was 800 pages long. It required a quantum processor just to convert the measurements. And every time they fixed one thing, 2 other things broke. "Commander," his engineer said, "the math doesn't work. The HAL coupling operates at 0.73 flux units, but the conduit needs at least 900 harmonic cycles to function. When we convert between the systems, we get a variance of—" "I don't care about the variance," snapped. "Just fix it." But they couldn't. The engineer had spent 2 cycles running calculations. The quantum processor had overheated twice. They had replaced the coupling, recalibrated the conduit, and rebuilt the node. Nothing worked. More sections failed. The pressure breaches spread. Ships began evacuating. On the 3rd day, a small transport docked at the emergency port. Barely noticed. He was too busy trying to prevent a reactor meltdown in Section 18. His second officer approached him with obvious reluctance. "Commander, the council sent help." "Finally, how many engineers?" "5. His middle eye twitched. 5 engineers for a station this size. Are they at least? "No, Commander, they're human." Felt his breathing sacs deflate. Humans, the species in the galactic community. They had only developed faster-than-light travel 2 generations ago. Their technology was primitive. Their understanding of advanced physics was laughable. They measured things with their body parts, for crying out loud. "This is an insult," said. "I agree, Commander, but they're all we have." The human team arrived in the control room 10 minutes later. Their leader was a small female with dark hair pulled back from her face. She wore a simple jumpsuit with the name CHEN printed on the chest. Behind her came 4 more humans, carrying cases of equipment. "Lieutenant Sarah, Earth Engineering Corps," she said. Her translator rendered her words in flat, unaccented galactic common. "We're here to help." Looked at her. She was tiny. Humans were always tiny, and she looked tired. They had probably pulled her from sleep to send her across 3 star systems to a dying station. "Lieutenant," he said, trying to keep his voice polite, "I appreciate the council sending you, but this is a complex situation. We're dealing with integrated systems from 12 different species across 800 years of construction. The calculations alone require—" "Can I see the schematics?" interrupted. Blinked all 3 eyes. Excuse me. The station plans, the layouts, whatever you've got. He pulled up the holographic display. 300 levels of station architecture filled the air, color-coded by species and time period. It was beautiful and terrifying. A maze of incompatible systems held together by prayers and patch jobs. Stared at it for exactly 10 seconds. Okay, she said, we'll have this fixed in 6 hours. The control room went silent. Second officer made a choking sound. One of the engineers started laughing, a high-pitched whistle of disbelief. 6 hours, repeated. Lieutenant, we've had 20 engineers working for 3 days. The precision standard alone requires. That's your problem right there, said. She pointed at the display. You've got 12 different measurement systems. Nobody can talk to anybody else. Every repair needs a translator. Every calculation needs a converter. You're spending more time doing math than fixing things. The precision standard is mathematically superior, said stiffly. It's calibrated to the fundamental constants of the universe. It's perfect. Maybe, said, but can you fix this station before it explodes? Opened his mouth, closed it, opened it again. No, he finally admitted. Right, so here's what we're going to do. My team is going to convert everything to metric. We're going to mark every pipe, every wire, every coupling with measurements that anyone can understand. We're going to use simple tools and simple math, and we're going to fix this station. You can't just abandon the precision standard. Looked at him with those strange human eyes. They only had 2, but somehow they seemed to see more than his 3. Commander, I'm not here to prove my system is better than yours. I'm here to save lives. You can file a complaint with the council later. Right now, I need you to tell me where the main power distribution center is. Something in her voice made stop arguing. Maybe it was the confidence. Maybe it was the exhaustion. Maybe it was the fact that she was the only person in 3 days who had offered him a solution instead of a problem. Section 43, he said quietly, Level 12. Thank you, turned to her team. Martinez, you're with me on power distribution. Jackson, Wu, start in Section 12 with those pressure breaches. Standard kit. Spray paint, wrenches, duct tape, and common sense. Remember, we're not here to be fancy. We're here to make it work. The humans grabbed their equipment and disappeared into the station. Watch them go. Spray paint, he said weakly. Duct tape. His second officer made a gesture of helplessness. What just happened? I think, said slowly, we just let a team of primitives take over our station. For the next 5 hours followed through the station. He told himself it was to supervise. Really, he just wanted to understand. She worked like nothing he'd ever seen. No careful calculations. No quantum processors. She looked at a coupling, pulled out a device she called a tape measure, and called out numbers. Her team wrote those numbers on the wall with spray paint. Bright orange numbers that anyone could read. This pipe carries coolant at 40 liters per second, she said, marking it. It needs to connect to this other pipe that carries coolant at 40 liters per second, so we use this adapter. She held up a simple metal piece. See? Same flow rate. Easy. But the HAL specifications say that pipe operates at 0.73 flux units, protested. I don't care what the HAL specifications say. I care about how much coolant moves through the pipe, and that's 40 liters per second. She installed the adapter. It took her 3 minutes. Next problem. They moved to Section 12. The pressure breaches were worse. The conduits were cracked. According to the repair manual, they needed to be replaced with identical conduits, precisely calibrated to 947 harmonic cycles, installed during a 3-hour ritual of resonance alignment. Jackson looked at the cracks, pulled out a roll of metallic tape, and started wrapping. What are you doing? Asked, horrified. Fixing the leak. That's not proper procedure. Does it stop the air from escaping? Checked his scanner, the pressure was holding. Yes, but... Then it's proper enough. Jackson finished rapping and moved to the next crack. It went on like that. Every problem the humans encountered, they solved with brutal simplicity. They ignored the manuals. They ignored the specifications. They looked at what was broken, figured out what it needed to do, and made it do that thing. His team put conversion charts on every wall. They marked pipes with colored tape. They labeled controls in 3 languages. They replaced complex interfaces with simple switches that had 2 positions, on and off. It was ugly, it was inelegant, it was an insult to engineering. It worked. 5 hours and 40 minutes after it had arrived, she returned to the control room. Her jumpsuit was covered in grease. Her hair had come loose. She looked exhausted. "Station stable," she announced. "All pressure breaches sealed. Power distribution balanced. You'll want to do proper repairs eventually, but this will hold for a few months." Stared at his control panel. Every warning light had turned green. The pressure readings were steady. The power flow was smooth. The station was humming along like it had been built yesterday. "How?" he asked. Smiled. It was a tired smile, but genuine. "We didn't overthink it. Sometimes the best solution isn't the one. Sometimes it's just the one that works." She and her team collected their equipment. As they walked toward their transport, called out, "Lieutenant." She turned. "Thank you," he said. "You saved a lot of lives today." "Just doing our job, Commander." She paused. "If you want some advice, write down everything we did. The Council is going to ask questions." After the humans left, stood in the control room, staring at the now peaceful displays. His second officer approached. "The other engineers want to remove all the human modifications," she said. "They say it's not proper, not standard." Thought about that. He thought about 3 days of failure. He thought about 5 hours of success. He thought about spray paint and duct tape and simple solutions to complex problems. "Leave it," he said, "all of it, and send a full report to the Council. Tell them everything." "Everything, Commander." "Everything, including the part where the humans fixed in 6 hours what we couldn't fix in 3 days." Word spread fast. Within a week, every engineer in the sector had heard about Station. The species that couldn't agree on what color emergency lights should be had watched humans fix a crisis with spray paint and common sense. Some found it funny. Some found it embarrassing. But everyone paid attention. 6 months later, Engineer Diplomat stood in the grand chamber of the Cosmic Engineering Council. The ceiling disappeared into darkness above him, held up by columns that predated human civilization. Around him sat representatives from 40 species, each one older and more advanced than humanity, each one looking at him with expressions ranging from curiosity to contempt. Was used to it. Humans were always the new kids, the primitives, the species that fixed things with hammers and hoped for the best. Today, he was going to change that. "Honored members of the Council," he began, "I come before you with a proposal. I propose that this Council adopt human engineering standards as the primary system for all galactic infrastructure." The chamber erupted. 40 species started shouting at once. They accused him of cultural imperialism. They said their harmonic systems were spiritually aligned with the cosmos. The HAL simply laughed, a sound like grinding metal. The Grand Architect, an ancient being of living light named Brightness of Dawn, raised one glowing appendage. The chamber fell silent. "Engineer," Brightness of Dawn said in a voice like distant bells, "please explain why we should abandon 12,000 years of tradition for the standards of a species that measures distance with their feet." Smiled. He had prepared for this, because our standards work, and I can prove it. He activated the holographic display. Numbers filled the air. Incident reports, repair times, casualty figures. Over the past millennium, this council has recorded 43,000 critical infrastructure failures. Average repair time, 4.7 cycles. Cost in resources, immeasurable. Cost in lives, too high to calculate. He changed the display. New numbers appeared, highlighted in blue. In the 6 months since station, human engineering teams have responded to 17 major incidents across the galaxy. Average repair time, 8 hours. 0 casualties. The chamber was silent now. Everyone was reading the numbers. The secret isn't superior technology, continued. It's standardization. Standardization so simple that anyone can use it. An engineer can read a human schematic. A HAL technician can operate human tools. A can double-check human calculations without a quantum processor. He pulled up images of human tools. A wrench, a tape measure, a level. These are our instruments, simple, cheap, effective. You can learn to use them in an hour. You can teach them to a child. An engineer stood. His name was and recognized him from the reports. Your tools are crude, said. Imprecise, they lack elegance. You're right, agreed. They are crude, but they saved station. They saved your life, Commander. Sat down slowly. Continued. Let me show you what makes our system different. He displayed a simple ruler. This measures distance in meters. 1 meter is based on an old Earth standard. It's arbitrary. It has no cosmic significance, but everyone can understand it. You can see it. You can measure it with your eyes. He showed them a thermometer. This measures temperature in Celsius. Water freezes at 0. Water boils at 100. Simple numbers, easy to remember. He showed them the humble wrench. This fits bolts measured in round numbers, 10 millimeters, 15 millimeters, 20. No complicated conversions, no quantum calculations, just simple math that anyone can do in their head. A representative spoke, her voice creating harmonics that the translator struggled to render. But our systems are more accurate, more aligned with the fundamental forces of the universe. That's true, said. Your systems are individually brilliant. I mean that sincerely. The precision standard is a mathematical masterpiece. The harmonic calibrations are beautiful. The HAL flux measurements are incredibly precise. He paused, letting that sink in. But they don't talk to each other. When you build something with 12 different measurement systems, you don't get 12 kinds of brilliance. You get chaos. You get station. He changed the display again. This time it showed the station itself, covered in human modifications. Orange spray paint, colored tape, simple labels in multiple languages. This is what we did. It's not pretty, but it works. And more importantly, everyone can understand it. A junior engineer from any species can look at our work and know exactly what we did and why. The Grand Architect spoke again. Why does this work, engineer? Your species is young, your technology is primitive, your mathematics is simplistic, yet you achieve results that elude us. Why? This was the question had been waiting for, the real question, the one that mattered. Because we designed our standards for the worst possible situation, he said quietly. We designed them for the dumbest human at their worst moment. When you're exhausted, terrified, and running out of air, you don't want to calculate quantum resonances. You don't want to consult an 800-page manual. You want a tool that fits in your hand. You want a measurement you can eyeball. You want a system you learned when you were 6 years old. He looked around the chamber. Human engineering isn't about being smart. It's about being reliable. It's about making sure that when everything goes wrong, anyone can fix it. Even an idiot. Even a human. Some of the species chuckled at that. Humans were known for their self-deprecating humor. I'm not asking you to abandon your traditional systems, said. Use them for specialized applications. Use them for your own infrastructure. But for shared spaces, for stations that connect multiple species, for emergency situations where lives are at stake, use standards that everyone can understand. Use standards that work when perfect fails. Brightness of dawn dimmed thoughtfully. You propose a practical solution, but you are asking us to set aside pride, to admit that simplicity succeeds where sophistication fails. Yes, said simply, I am. And if we refuse? pulled up one more image. It was a photograph from station. Sarah and her team, covered in grease, grinning at the camera. Behind them stood looking utterly baffled. "Then the next time a station fails, you'll call us anyway," said. "And we'll come fix it with spray paint and duct tape. And everyone will know that the humans saved the day again. Is that what you want? Or would you rather implement these standards yourselves, on your own terms, and take credit for a practical improvement to galactic safety?" The Grand Architect's light pulsed in what might have been amusement. "You are a clever diplomat, engineer." "I'm a terrible diplomat," said honestly. "I'm just an engineer who's tired of watching people die because we're too proud to use simple solutions." The council debated for 3 hours. The arguments were passionate. The abstained from the vote, too proud to admit defeat but unwilling to vote against safety. The nearly walked out twice. The HAL demanded amendments. But in the end, the vote passed. The council would transition to human-based standards over the next 5 years. Local systems would be permitted for specialized applications. The official name would be the Practical Integration Initiative, because admitting they were adopting primitive human standards would have been too embarrassing for some species. Didn't care what they called it. He cared that it would save lives. As the session ended, approached him. The commander looked older than his file photo, tired. "Engineer," he said formally, "I voted in favor of your proposal." "Thank you, Commander." "I did not want to. I still believe the precision standard is mathematically superior." 3 eyes met too. "But Lieutenant taught me something at station. She taught me that engineering is not about perfection. It is about reliability, and your standards are reliable." "They're reliable because they're simple," said. "And they're simple because we humans are not very smart. We need things to be easy or we mess them up." Made a sound that might have been a laugh. Perhaps being not very smart is a kind of wisdom. Perhaps we have been too clever for our own good. After left, stood alone in the empty chamber. He thought about Sarah fixing a dying station with spray paint. He thought about 12,000 years of tradition bending to 5 hours of practical work. He thought about how humanity had changed the galaxy not with weapons or wonders, but with wrenches. His communicator buzzed. It was herself calling from Earth. "I heard the vote passed," she said. "Congratulations." "You should be here," told her. "This was your win, not mine." "Nah, I just fixed a station. You changed the galaxy." She paused. "They're really going to use our standards, meters and kilograms and all that." "They really are." Was quiet for a moment. "That's going to be weird. We've only been in space for, 60 years, and now everyone's going to measure things the way we do." "Apparently simple beats sophisticated." "Simple is sophisticated," corrected. "It's just sophisticated in a different way. Anyone can make something complicated. It takes real skill to make something simple enough that it works every time." Smiled. "You should write that down. It sounds wise." "It sounds like something you'd put on a motivational poster. Listen, I've got to go. They're sending me to fix another station. Some kind of cooling system problem." "Use duct tape," suggested. "Always do. Take care." She disconnected. Stood in the dark chamber for a few more minutes, thinking about the future. In 5 years, every station in the galaxy would have human measurements on the walls. Every emergency kit would have human tools. Every engineer would learn metric in school, alongside whatever traditional system their species preferred. And somewhere, somehow, humanity had become the standard that others measured themselves against. Not because humans were smarter, not because humans were stronger, but because humans were simple. And in a complicated galaxy, simplicity was the most sophisticated thing of all. 20 years passed. A generation grew up knowing only human standards. Young engineers learned metric in their first year of training. They learned about the old systems in history classes, the way human students learned about cubits and furlongs. The precision standard became a curiosity. The harmonics became a specialization. The HAL flux measurements became a footnote. Infrastructure failures dropped by 87%. Response times improved so dramatically that some species suspected the old numbers had been exaggerated. New species joining the galactic community were astounded to learn that the universal standards had been invented by one of the youngest spacefaring races. At the Imperial Academy, Commander gave his annual lecture to the new class of engineering students. He was old now, his 3 eyes dimmed with age, his movements slow. But his mind was sharp, and the students always packed the auditorium to hear him speak. "Today I want to talk about failure," he began. "Specifically, my failure at station." The students shifted in their seats. They knew this story, of course. Everyone knew this story, but hearing it from himself was different. "I was the lead engineer on site," continued. "I had 30 years of experience. I had mastered the precision standard. I knew quantum mechanics, harmonic resonance, gravitational flux theory. I knew everything there was to know about engineering." He paused, letting the silence stretch. "And I failed. For 3 days I failed. The station was dying. Millions of lives were at risk, and I could not fix it. Do you know why?" A young student raised a tentacle. "Because the systems were incompatible, Professor." "Yes, but that is not the whole answer. The systems were incompatible because we made them incompatible. We, believed our way was the only way, the best way. We built our systems to be perfect, and in doing so, we made them impossible to integrate with anyone else's work." He pulled up a hologram. It showed Station as it had been 20 years ago, a nightmare of tangled systems and desperate patch jobs. This was the result of 12,000 years of everyone believing they were right, everyone optimizing for their own definition of perfection, everyone refusing to compromise. The hologram changed. Now it showed the station covered in human modifications, orange spray paint, colored tape, simple labels. "The humans fixed this in 5 hours. Do you know how?" "They used simple standards, Professor," another student said. "They converted everything to metric." "They used simple standards," agreed. "But more than that, they refused to overthink. They looked at a broken pipe and asked, 'What does this pipe need to do?' Not, 'What does the manual say?' Not, 'What would be the most elegant solution?' Just, 'What needs to happen here?'" He reached into his desk and pulled out an old wrench. It was battered and stained, with human letters spray-painted on the handle, CHEN. "Lieutenant Sarah left this behind at station. I kept it. This tool is crude, imprecise. It would be an insult to any craftsman, but it saved 17 million lives because it was simple enough that anyone could use it." He passed the wrench to the front row. The students examined it with curiosity and barely concealed contempt. It was so basic, so primitive. "I want each of you to hold that wrench," said. "Feel how simple it is. Notice that there are no quantum processors, no harmonic calibrators, no computational matrices. It is a piece of metal shaped to turn a bolt. That is all. And yet it is one of the most important engineering tools ever created." The wrench made its way through the auditorium. Some students held it gingerly, as if it might contaminate them. Others studied it more thoughtfully. "The humans taught us that engineering is not about being clever," said. "It is about being reliable. A system that works every time is better than a system that works perfectly some of the time. A tool that anyone can use is better than a tool that only experts can master. A solution that takes 5 hours is better than a perfect solution that takes 3 days." He looked at his students. They were young, eager, full of confidence and pride, just like he had been once. "I know what you are thinking," he said gently. "You are thinking that you are better than this, that you deserve better than crude human tools and simple human standards. You are thinking that the old ways were superior, and that we have lowered ourselves by adopting primitive methods." Several students had the grace to look embarrassed. "I thought that too," admitted. For years after station, I resented the humans. I resented their success. I resented the fact that their simple approach had succeeded where my sophisticated methods had failed. I resented having to teach young engineers to use meters instead of the precision standard. He sat down on the edge of his desk, a gesture that would have been undignified when he was younger. Now it just made him seem approachable. Human, almost. But I was wrong. The humans did not lower us. They saved us. They saved us from our own pride. They showed us that there is sophistication in simplicity, that there is wisdom in making things easy, that the best solution is not the cleverest one but the one that works when everything else has failed. The wrench came back to him. He held it up, turning it slowly in the light. This tool is now in the Council's Museum of Engineering. It sits next to the original specifications for the precision standard. Two different philosophies, two different approaches. One complex and beautiful, one simple and reliable. He set the wrench down. I know which one I trust with my life. The lecture ended. The students filed out, chattering among themselves. Some were convinced, others were skeptical. That was fine. Remembered being skeptical too. Experience would teach them just as it had taught him. After the last student left, sat alone in the empty auditorium. He pulled up his personal communicator and scrolled through his messages until he found the one he was looking for. It was from Sarah, sent 5 years ago when she had been promoted to Chief Engineer of the Galactic Infrastructure Division. "Heard you're teaching now," the message said. "That's good. Train them right. Train them to ask, does it work, before they ask, is it perfect? The galaxy needs more engineers who fix things instead of overthinking them. Thanks for believing in us, we couldn't have done it without you trusting us to try." Had never responded to that message. He had been too proud, but now he typed out a reply. "Lieutenant, I have been teaching your methods for 15 years now. Every student who graduates from this academy knows how to use a wrench before they learn quantum mechanics. They know how to read a meter stick before they study gravitational flux. They know that simple and reliable beats complex and perfect. You did not just fix station. You fixed the way we think about engineering. Thank you." He sent the message and stood up slowly. His joints ached. He was too old for this. But someone had to teach the young ones. Someone had to make sure they understood. Across the galaxy, in the Galactic Infrastructure Division headquarters on Earth, Sarah sat at her desk reviewing reports. Her hair was gray now, and her hands showed the scars of 40 years in engineering. But her eyes were still sharp, still looking for problems to solve. Her assistant knocked on the door. "Chief, there's a situation developing at the Orion Gate. Power distribution problems." Stood up and grabbed her toolkit. It was the same case she had carried to station 20 years ago. The same spray paint. The same duct tape. The same simple tools that sophisticated people called primitive. "What's the response time estimate?" she asked. 6 hours, Chief." "Tell them 4. I'm not as fast as I used to be." She headed for the door, then paused. "And send a team of trainees with me. They need to learn how this is done." "Yes, Chief. Should we send them the repair specifications?" "No specifications. Just tell them to bring wrenches and common sense. That's all we need." At the Orion Gate, the local engineers had been working on the problem for 2 days. They had consulted manuals, run simulations, and built computational models. The power distribution was still failing. Ships were being rerouted. The local economy was suffering. When transport docked, the station commander met her at the airlock. He was a young Hal, all enthusiasm and technical knowledge. "Chief, thank you for coming. We've been analyzing the power flow matrices, and we think the problem is in the quantum regulation system. If we recalibrate the—" "Show me the problem," interrupted gently. They walked through the station to the main power center. It was chaos, cables everywhere, flashing warning lights, the smell of overheated metal. 3 different engineering teams were arguing about mathematical models. Looked at it for 30 seconds, Then she turned to her trainees. "What do you see?" A young human named spoke first. "Too many connections, Chief. The power's trying to go through 12 different relay points. It's getting lost in the complexity." "Good, what else?" A trainee raised a crystalline appendage. "The bypass routes are incorrectly labeled. Section 7 says it goes to the main grid, but it actually feeds back into Section 3. "Excellent, what's the solution?" And they looked at each other. The young human pulled out a marker. "Relabel everything, simplify the routing, cut out unnecessary relay points." "How long?" asked. 3 hours, Chief." "You've got to get to work." The station commander watched in amazement as team ignored all the sophisticated analysis and just started fixing things. They traced cables by hand. They labeled junctions with markers. They eliminated unnecessary complexity. They made the system simple enough that anyone could understand it. 2 hours and 15 minutes later, the power was flowing smoothly. The trainees were exhausted but proud, was covered in grease and grinning. "That's it?" the commander asked. "It." "That's it," confirmed. "You were so busy optimizing the system that you made it too complicated to work. Sometimes the best engineering is just taking a step back and asking what you really need." As they prepared to leave, the trainee approached nervously. "Chief, can I ask you something?" "Of course." "Why do we do it this way? I mean, my people have harmonic systems that are mathematically more elegant. They have standards that are more precise. Why do we use these simple human methods?" Smiled. It was a question she had answered 100 times and it never got old. Because when you're in trouble, you don't want elegant. You don't want precise. You want something that works right now, no matter who's doing the repair. Our methods aren't the best. They're just the most reliable. And in engineering, reliable is better than best. The trainee considered that. "So we're not trying to be perfect. We're trying to be dependable." "Now you're getting it. Perfect is the enemy of good enough, and good enough saves lives." Back on Earth, filed her report and went home. Her apartment overlooked the ocean. She stood on the balcony, watching the sunset, thinking about station and all the years that had followed. Her communicator buzzed. A message from. She smiled as she read it. The old had finally replied to her message from 5 years ago. Better late than never. She typed a response. "Commander, you trusted us when no one else would. That meant everything. Keep teaching them right. The galaxy needs engineers who care more about fixing things than about being clever. We're proof that sometimes the primitive approach is exactly what everyone needs. Thank you for believing." She sent it and went inside. Tomorrow there would be another station, another problem, another chance to show that simplicity worked. But tonight she could rest. Across the galaxy, on 100 different stations and 1,000 different ships, engineers used human standards without thinking about it. They measured in meters. They calculated in Celsius. They fixed things with simple tools that fit in their hands. The young ones had never known anything different. The old ones had learned to accept it. And sometimes, late at night, an older engineer would tell a younger one about the days before, about the precision standard and the harmonics and the